A charged particle is moving in the xy plane as shown in the picture. The particle's velocity vector has a positive x component and a negative y component. So that's the vector in the fourth quadrant of the xy plane in the picture. There's also a magnetic field in the xy plane with a positive x component and a positive y component, and that's the vector in the first quadrant on the picture. We'd like to find the acceleration of this particle produced by the magnetic force. So the acceleration produced by the magnetic force is going to be equal to the magnetic force divided by the mass of the particle. So the mass is given, the particle's charge is also given. We can calculate the magnetic force using the particle's charge, velocity, and the magnetic field vector. And then if we divide that force by the particle's mass, that will give us the acceleration. Here I have set up my formula. Acceleration equals magnetic force divided by mass, and magnetic force is equal to Q times V cross B. Now, how to do V cross B? I have also substituted my numbers below, so we can see the two vectors, and we need to multiply them by a cross product. Now, both vectors v and b have only x and y components, right? And we're going to do the cross product term by term. So for instance, this term cross product, this one here. Now that will be I hat times I hat, that's 0, right? And then the second component of vector v time cross product the first component of b. Well, what do we get from that? We get j hat times I hat. The result of that cross product is going to be negative k hat. So j hat times I hat is negative k hat. So we'll basically calculate, multiply the numerical values, and then we will multiply the result by negative k hat. Likewise, then we're going to multiply or take the cross product of the first component, x component of the velocity vector, by the y component of the magnetic field vector. That's from there we get I hat times j hat, that's positive k hat. And finally, the last two terms, we get negative j hat times j hat, that's again 0. So we only have two surviving terms from this cross product, and one brings a factor of positive k hat, the other one brings a factor of negative k hat, and as expected, the magnetic force will be in the z direction. It only has a z component. Why is this expected? Because vectors v and b lie in the xy plane, and the force vector should be perpendicular to the plane defined by the velocity and magnetic field vectors. So let's go ahead and calculate this numerically. Here's how we do the cross product. Again, I'm following the unit vector cross product rule that I have summarized here. So we have two terms surviving. This first term comes from the cross product of the x component of the velocity vector by the y component of the magnetic field vector, and this second one here is the result of the cross product of the y component of the velocity vector by the x component of the magnetic field vector. Again, both of the cross product results are in the z direction. Note that the second term here has two negative signs, so those cancel. We get a positive result from that, and the first term is also positive. So then the overall force vector is in the positive z direction. And that's expected if you do the right hand rule for v cross b. Align your right hand in the direction of v and then curl your fingers in the direction of b towards the upper right corner. Your thumb will be pointing towards you, that is out of the page, and that is the direction of the positive z axis. So the magnetic force points in the positive z direction, and acceleration also points in the same direction, because acceleration is just force divided by mass, which is just a scalar positive number. So acceleration and the force point in the same direction. And when we do the calculation, keeping three significant figures, we get acceleration vector 0.700 meters per second squared in the positive z direction. That's plus k hat.